Hi everyone. In the last part of this virtual field trip, we're going to bring all of this information together to generate a geological history of the outcrop, as well as record the information we have collected from this site. So a geological history just tries to bring everything together in the order in which they happened. So in our case, first of all, the sediment was deposited in layers, and hopefully you were able to determine that this was in an ocean environment. That sediment settles out in quiet water to form these very nice flat lying sedimentary beds. That ocean then dried up and tectonic forces started to deform those beds. With continued tectonic forces, the folds in the sediment became much more obvious, and we then started generating vertical beds. This also generated topography, which started rivers flowing over the landscape. And with continued tectonic processes and uplift and mountain building, we then were able to generate much larger river systems, and hopefully you were able to deduce that Unit 2 was in fact a river environment. Now, bringing all this together, what we can actually observe is the presence of what we call an angular unconformity. And this is basically where we have missing time. We call this an angular unconformity based on Hutton's observations. And Hutton came to realize through this observation of the relationship of those two units, these rocks represent a significant amount of time, with the erosional surface representing a significant time gap between the deposition of Unit 1 and 2. Remembering between the deposition of Unit 1 and Unit 2, we had to deform those beds, create enough topography for then Unit 2 to generate large river systems that erode into Unit 1. We actually know through dating techniques now that there is approximately 120 million years time gap between Unit 1 and Unit 2, which is a really significant amount of time. For the final exercise relating to this virtual field trip, I would need to draw the outcrop. It's really common practice when in the field to record observation using sketches. They help us highlight key features and observations and give a useful summary of an outcrop, something that cannot be done with a photo alone. Yes, you can take a photograph of the outcrop, but you can't highlight key features or annotate where certain key features are and what they represent. Now, you really don't have to be good at art to draw a geological sketch. My secondary school art teacher can confirm that I am not an artist, but I am able to draw a geological sketch that conveys and records important information. A photograph is an important initial additional data source, but you cannot easily annotate or highlight these key features. You can see from the examples here that when I give you these sketches, you know exactly what it is, what you're trying to understand, particularly the ones that have got annotations on them. Whereas with a photograph, it's really hard to understand what it is I'm specifically trying to record and tell you. So I'm just going to guide you as to what we do when we draw a sketch. The first thing that we need to do is put a title. Where is this sketch? So we're going to just pop our title here. So for this particular outcrop, we're going to title it Siccar Point Unconformity Sketch. We're also going to put an orientation just so that people can see which way we're reviewing and hopefully be able to recognize the same outcrop if they go there and see exactly where you've taken that sketch from. I've also just popped a photo number on there so that I know exactly which photo to look at if I want to go back and look at my photographs. The other thing I've done is actually taken away everything else in that image. I've just grayed it out. And that's because although you can't do this when you're in the field, the key thing to do is to only concentrate on the key geological information that you're trying to convey. You don't have to be able to draw the nice rippling sea surface or anything like that. We're just going to ignore that because that's not the information that we want to record. The next thing we do is draw the largest feature. So in this case, we're going to draw the outline of the outcrop. To help us build this sketch, we start off with, first of all, putting in that framework. And then we start filling in the detail. So the next big feature for me is to put that unconformity surface, that erosional surface where Unit 2 erodes into Unit 1. I'm now going to start filling that detail in, drawing in those very shallow dipping beds in Unit 2. And then I'm going to draw in the vertical units of Unit 1. I'm then going to go into a little bit more detail, and you'll see, particularly when you use the gigapan imagery, that you can actually start seeing some large class present. So I've drawn a few of those in as well. Finally, we annotate the sketch, and this is to really convey the key information. So you can see that I've labeled the angular unconformity and even highlighted it using a different color because it's a really important observation. I've then put a few brief descriptions of those rock types based on the which you can do based on the information that is given in the workbook. So if I take that image away, this is something that you will end up having towards the end of this exercise. Although I've not done it in this example, you can also add a little bit of color, although it's recommended to only very lightly shade it to highlight key features. So in this case, the way in which we first of all were able to distinguish the two rock types was that Unit 2 was quite red in color, whereas Unit 1 was gray. So it could be a good idea to very lightly shade that information in. So what I would like you to do for your final exercise is to go back to the workbook and draw a geological sketch of Siccar Point. I've provided a photograph where I would like you to draw what I would like you to draw, but also please do use the Gigapan imagery and the 3D Sketchfab outcrop model to help you fill in that detail that you can't get from a photograph alone. Now, before you move on to the workbook, I hope that you've enjoyed undertaking this virtual field trip and that you can see how geoscience lets us interpret the world around us based on our observations. For me, I love understanding how Earth looked like in the past, understanding how environments have changed through external forces such as tectonic processes or climate change, with a view of better trying to understand how these landscapes will change in the future. For example, we know that our present day climate is getting much warmer, but how our river environments or our oceans going to respond to that change? We can look to the rock record to help us understand what has happened to these environments in the past when those changes has happened. For me, it's also about the people I meet and work with. I've met a great variety and range of people from different cultures, from different countries, and I've become lifelong friends with them. I've also created a special bond with colleagues. There's nothing like going into the field together and exploring these amazing landscapes. If you have any questions relating to this exercise, please do not hesitate to get in contact. And I will look forward to seeing you all in our live session. Thank you.